Okay, so things seem to be recording. Right, when you last joined me, we were still doing a different simulation, but now we've moved to London. Let's focus on London, 1940. That's the simulation. There were 8.5 million people living in London in 1940. So we need a simulation that can handle 8.5 million people. So we've come back to simulated ape. Here the command line for simulated ape. And we're looking to see how many we can run. So I've made some notes here. This is actually the roadmap for the ApeSDK, so you can find this document. And I've already tested it out, and I've found that there are a couple of bottlenecks around the location and the genetics to provide uniqueness. Now, what I wanted to do was actually make the genetics just a bit smarter. So let's do that. It's never been like a live demo's ever ended in crashes or other stuff. So let's get this back into the code. Let's get the live genetics back into the code. And what this is saying is if we create an ape, it needs to have unique genetics. If we create an entity, a lambda, they should have unique genetics. So we have here. So now we go to the unique genetics, and it goes through unique genetics, and it goes through the number, which should relate to the genetics, I would imagine. Unique genetics, number comes through here. We come back to body genetics, number, jump to definition, body genetics. Let's see where it's used. So we're trying to see how we can pump up the genetics, so to speak. So here's the genetics. I know these are the number of apes. Okay, so it goes down and it sees the genetics. So maybe we're going the wrong way here. Maybe we need to go back here. Genetics unique. Goes through the number. Here we go. Being genetics, it's a comparison. So we're going back to the comparison. And we need to find the definition. Here we are, chromosomes. Fancy that. So we now need to find the definition of chromosomes. Wow, 4 chromosomes. Okay. Let's see what happens if we change this to, say, 8 chromosomes. Let's make the point by doing it as a multiplication so we can see after the fact. Okay. 8 chromosomes. I kind of want to do 16 chromosomes. Now, will this blow up huge? This is where we have these genetics. We probably need to reprogram these genetics at some stage to be... How many genetics are there? Wow, lots of different genetics. We probably need to... Okay, we probably need to expand these through that at some stage. But let's just see. It just means that the early ones are the genetics of importance. Okay, that looks okay. Let's see what the top... Well, we probably should have done the timing without that. Humor me, if you will. Well, let's put it back, and I'll show you just how bad it is. And we'll see. Okay, so I put in various debugging stuff so we can see what's going on, but let's run it. Takes a bit of time. It was a little bit. Spits out a version eventually. Here we go. Okay, so you'll see this is 0.700. It's a little bit further than that, which was the previous number. So what we want is to run for 1 minute, which will just pick up the apes. So here we go. We're looking to reach 57,344 apes. Well, look how slow this is. It's okay. But this is the counting. The pace here is important. It's also nice to see the memory usage and various other things just shooting up. Okay. I think we get an indication of how slow this thing is, right? Searching through, finding unique genetics at each stage. Let's just stop this thing here. So let's make this a bit bigger. Let's make this 16 chromosomes. Let's start this thing again. And with some luck, we will run 1 minute. Let's say this time. Okay, same number. Still pretty slow. Still pretty slow. Wow. Okay, so making big genetics wasn't the immediate be-all and end-all that we were hoping for. This is why it pays to try something before you demo it. Okay. Clearly, just the reshuffling is busy enough. Wow. Okay. Let's move that back. It wasn't an easy fix as I thought it might be. Let's just indicate, say that. Let's go back to unique genetics and let's just comment that out. Here we go. Back to where we were. Let's comment that out. So do no more. And let's try this out. Okay, we're trying to get to 57,000. Well, that came up even faster though. You're going to admit that was a little bit faster. Okay, run 1 minute. Okay, here we go. So, this one I tried a little earlier. It was, I am picking a large number here. Okay, so this is the cadence that we want. It's going to be a little slow. It probably won't actually reach the number we want because it's too close. It's pretty close though. Anyway, so what we're doing here is we're trying to, we'll just leave the genetics unique as still being a bottleneck. What we're trying to do here is reach close to the 57 number. Not quite there yet. Let's see what Sim says to us. Oh, no, not quite. What we're looking for is a large number of adults. And probably that's a 1 because we're a minute in. So just try and simulate it to a minute. This is very slow. So imagining it's a exponential speed. Very slow. We're just waiting. But I mean, what this illustrates really is that if you're simulating a small number of apes, relatively easy. But once you get into a level of detail, there's a lot of additional stuff that you need to kind of gather together. And we're not even getting debugging. Okay. Let me at least show you how we can make these debugging a little bit better. Count number. That'll be a bit far. Well, at least it'll be speedier. We should see that a little faster. Okay. You see? Clipping along. That tells you. So the aim is to reach 57,000, which it seems to be getting to. And actually projecting 57,000 unique names is always fun. Well, they're not unique names anymore because the genetics aren't unique. But anyway, this indicates the kind of problems that we're looking at, we being me. That we've just got to get a simulation with a sufficient detail, and obviously we're going to get down into what we really need to simulate Londoners in 1940. But I did want to get to a relatively large number here. I think 64K is still too small. It needs to probably be, I don't know, I would say in the vicinity of maybe 256K, just to say, hey, you know, this is this working. And there's a bunch of additional stuff over in the roadmap docs. So what I'm looking at here, let's have a look at the London 1940 roadmap doc. So the roadmap doc for urban. Ignore the red. I'm not sure why it shows red. In any case, so here, this is the first one. So can we do this with the ApeSDK? Do we need new memory, new simulation methods? This is the stuff I'm exploring currently. Very early on. Agent pathing, good simulation environment. This is back to editing the maps. We can use Urban initially as well, just to get a simulation environment running. But yeah, we need to go back and improve the JSON and get everything looking like London, basically. And actually, I think in terms of the maps, we're pretty good on that. I'm writing a grid analysis package. So basically, MapEdit will use much smaller PNG files and rather than load large PNG files. And I think that'll make it tick along faster. So rather than having to load, what would it be, about, I don't know, 400 megs of PNG. The aim is that it'll load probably, I don't know, 30 or so megs of PNG at any given time, and just enable London editing in that kind of time frame. So we're still ticking along here, making our way to 57,000 quite comfortably. But this just indicates, this is a pre-existing simulation. It's not heavily optimized. I mean, I haven't really gone in and optimized it for profiling yet and just seeing where all the time is taken through this. The aim is just to get amount of memory actually allocated and used. So 8.5 million is incredibly, I mean, obviously with existing ApeSDK, very ambitious. So we're going to have to use a bunch of smarts around how we actually get this thing to finally simulate 8.5 million folks. But this indicates where things are currently. I normally show maps of London. Apologies for not doing that with this particular one. But I just wanted to show where the road maps were heading and certainly what this thing actually looks like in a very simple command line way. But to be continued. Another video, no doubt, in the foreseeable future.